Today I will share my thoughts on fine-tuning LLMs. So I will pick Llama 2 model for the discussion. So I thought I will make the session a little bit broader as well. So I will start with the customization basics. So why do you customize in the first place? The foundation model and what are the different steps you take to do it? And then I will take you through the process. And I have my notebook as a backup because it's running on a Google Collab platform. So sometimes when you run the train, you have resource constraints. But what I plan to do, I'll run through the code. I put it in the slide, and then if possible, we can run it on the notebook as well. Just a disclaimer. So I'm learning about fine-tuning the models. So I know theoretically, but getting my hands dirty. I'm also a learner like you. So I'll try my best to explain as much as possible. But if there are any specific technical questions about the fine-tuning that I could not answer, I can assure you that I will follow up with an answer. So let me start. So the topic of this discussion is customizing foundation model, how to make LLMs work for you. So I am Ashwin. I am a technologist. So I like to tinker around with multiple technologies. So right now with GenAI, but at work I focus on data platforms, cloud transformations for our clients. I'm based in Singapore. My passion is to write. So at the bottom I've given two links that I'm quite active on these days. First is the link to my newsletter, and the second one is to my LinkedIn profile. My mission is to help and guide engineers to grow into tech leaders. That's my mission, and that's what my content on these two platforms are focused on. I try to do this through my newsletter, my blog posts, ebooks, and courses. So starting with the topic, foundation models are, so there is no question about it. So they are trained on a huge corpus of public data. Then they are robust, versatile. Is very good for our day-to-day tasks, because I'm pretty sure most of you are using LLMs to summarize text, to tighten an email that you're writing. So a lot of general questions that the foundation models are great. And then some of the very popular and strong foundation models. So this slide I think will be outdated in a week or two, because there are so many models coming out every day. So you have your GPTs, you have your Llama 2, you have your Cohere models, Cloud. So there are multiple foundation models that are really great for everyday use. But I would like to see them as animals in the wild, right? So they can do a lot of things, but when you want to domesticate them, right? So when you want to bring them to your home, want them to do specific tasks, so they need to be customized, and that is where the model customization and fine-tuning is one of them, right? So we go through the different ways and different scales, I think, in which the models can be customized. But why do they need to be customized? So if you want the models to do what we expect them to do in various parameters, various aspects, so in my opinion, the models need to be customized. So that's one of the primary reasons. So there's an analogy that I found in one of the deep learning courses. So I've given the course link below. It's a very nice course. If you haven't done it, I suggest you to go and take a look at it. So a good comparison or analogy is between a GP and a specialist, right? So your foundation model is like a general practitioner. You go with a symptom, probably looking at your symptoms, looking at a little bit of a past history. So the GP is going to give you a medicine. In 90% of the cases, it's going to cure this condition that you go with. A fine-tuned model, you can compare it to a specialist. So it not only takes your basic symptoms and correlation between your symptom and the treatment for you. It can also take more information about you. Maybe there are some specialized tests that they will ask you to do and so on, which gives you the additional data. And then you're going to get a much more specific diagnosis, right? In the first case, it could probably be acne. In case of a skin irritation. But in the second case, it could be a bit of a specific acne, inflammatory, non-inflammatory, and so on. So this is a good way to look at what a foundation model and a fine-trained model can do. I thought this is a good analogy that we can use to understand. So the other reasons, in my opinion, to customize a model, the first one is performance. So we normally fine-tune models to train on data specific to the use case of interest and get a reliable output. Because with foundation model, the reliability of output is not something that you can control. But with a fine-tuned model, you can get more level of control on the output that the model generates for you. The second one could be to optimize costs. This is to reduce costs by deploying a smaller model that gives better performance. So in the latest slide, I'll show you the different scales of fine-tuning, but using PEFT, for example, by training a few parameters of a model, we are able to spend less, at the same time get a better performance out of the model that we are looking for. And lastly is on personalization. So by training, by fine-tuning your models with prompts or set of data sets, you'll be able to control the style, the tone, the format, or the other aspects of the output that are coming out of a foundation model. So these are three prominent reasons I see why somebody or any organization wants to customize a model. Yeah. So stop me at any point in time if you want to add some inputs or want to have a discussion, happy to do that. So there are different ways to customize a model. So broadly, I would put them under three categories. Yeah. So starting from left to right. So I see them as least costly, I would say, and faster to more costly and takes more time. On the left is a simple one, that's a prompt engineering. So this is something that you do, it's a non-technical way. You don't go and work with the inner workings of the model. So you train a model through prompting. Yeah. So you have 0, 1, few shot prompting. 0 prompting is one where you use the model as is and rely on the input. So 1 and few shots is where you tell the model that the output that you're expecting, and the model can do a little bit of fine tuning to the way that you expect it to. So advantages here is faster to implement. So it's efficient for simple use cases. So for example, if you want to set up a Q&A bot or a customer service bot, where you want it to train on the data that you have, your organization process, for example, this is the easier way to go, and all the popular models support this. Yeah, so and it's also useful for enhancement for specific skills. So PEFT, which we will discuss in this particular session, is somewhere in between. I would call it as a hybrid approach. And then the industry terminology for this is also delta tuning, right? So this is nothing but you customize a subset of LLM parameters. So a model of LLM is based on parameters. The higher the parameter, more breadth it covers. So, but customizing all the parameters of a model is going to be really, really expensive. So you need GPUs, multiple GPUs that are going to run, and it's cost intensive. So the cost versus benefit of tuning all the parameters of a model is most of the times is not very efficient. So the PEFT is somewhere in the middle, where it's faster, not resource intensive. The example that I'm going to show you can even run on a commercial hardware, for example. And then sometimes it's efficient based on the base model of the training data. So if you have a really good training data that you use to fine tune a model using PEFT, it's going to give you a much better performance than a full-fledged fine tuning. Yeah. So on the right hand side, you have the fine tuning where you tune all parameters of a base model. So here typically the approach is to host the base model, you fine tune and serve. And this is what a lot of organizations do. So if they want to have a private LLM that they want to use for their organizational use cases or commercial use cases, so this is what they do. And then if you have deep pockets, this is a good approach. So it's slower, it takes time to fine tune the model, but the output is also similarly good. So you have significant performance gains. And to do this fine tuning, it's not only you tune all the parameters, it also requires vast data points on which you will be able to fine tune. So in my opinion, so these are the three broad categories in terms of increasing complexity. So look at how can you customize a foundation model. Yeah. So next slide, a little bit of zoom into PEFT. So a PEFT approach, it gives you, as I said, comparable performance compared to full fine tuning, while you touch only a small number of trainable parameters. There are 4 different types. Prefix tuning. So you have your pre-trained LLM frozen. So this is pre-trained is your foundation LLM. So you have a vector that has parameters added to the input embedding at the each transformer layer. So this is assuming that your model uses the transformers. So you have these parameters added to the embedding. So the embeddings is nothing but your conversion of the data sets into tokens, for example, which the model understands. And then these parameters are added to multiple layers, multiple transformation layers. So how many ever transformation layers has? So you do this at each layer. So this is prefix tuning. And then this is more complex than the other ones that you see on the right, because you do it at every layer. And then the second one is prompt tuning. So this is a variant of, I would say, prompt engineering, but doing prompt engineering more with an automation, right? So here, what you do, you have the vectors, so which has your the fine tuning data that are added only at the input layer. So this, think of it similar to prompt engineering, where instead of you prompting, so you are basically training at the input layer with the prompts that are added as vectors. Okay, so this is a prompt tuning. P-tuning is a variant of prompt tuning, so it automatically searches and optimizes prompts. So prompt tuning is tuning it or training it with a fixed set of prompts, while P-tuning is similar to prompt tuning, but it has a dynamic generation or dynamic optimization of prompts in a continuous space. It uses an LSTM model. And the last one, which we will see in the example today, is the LoRa, the low-RAN adaptation. So this adds the pairs of update matrices. So you use the existing weights, you update the existing weights only where you want to fine tune, and then you train only on those newly added weights. Yeah. So these are 4 different mechanisms which are quite popular. There are other mechanisms as well, and these are the quite popular ones. So where you will use to fine tune your foundation models.